Okay, hello there, epidemics. Welcome to class. We've still got a little bit more to talk about with malaria. I think today's stories will be interesting. We're going to talk a little bit more about how malaria impacted our history. So I want to remind you, there are assignments due tomorrow. And the project is due a week from Sunday. So for you guys, I am not going to I will not post new assignments this week, so you can work on the project. And we're coming up close to the end of the semester. We've got, wow, 3 more meetings after today. Geez. So the last lecture will be May 2nd. And the last set of assignments will be due on May 7th. Okie dokie then. So we've talked about malaria and how it originally came about in Africa, and how we've had some genetic mutations through time to help people resist infection with malaria. These are common across the entire world, but much more common in people of African descent because the strain of malaria in Africa is much deadlier than the strains that we see in other parts of the world. So what I want to talk about now is malaria in the Americas. So this is North, Central, and South America, sometimes called the New World. There wasn't malaria in the Americas before the Europeans started invading. So before Christopher Columbus arrived in the New World. Remember that when the Europeans arrived, their diseases, the smallpox, the measles, those nearly wiped out the people who were already living in the Americas. And at this time point, malaria was actually widespread throughout Europe. We don't think of Europe as a place where there's a lot of malaria today, and it isn't very common in Europe today, but at that time, malaria was there. Excuse me. And so the Europeans brought malaria to the New World in their blood supply. And then when they started bringing in slaves from Africa, a lot of those people would be infected with malaria. And that was another way malaria was getting to the Americas. And now malaria is firmly established in Central and South America. Varying degrees of how widespread it is, but it is in lots of places in these areas. And, you know, things went on, time passes, and some Jesuit missionaries were traveling through South America in part of the Andes mountain range. And they noticed that the local Quechua, fingers crossed I'm pronouncing that one right, Quechua people use the bark of the chicona tree, which is pictured here, to treat fevers and chills, among other things. So it was a useful tree to treat various ailments. And it turns out that the bark does help reduce the symptoms of malaria and help people survive long enough that their immune system will succeed in getting rid of the malaria. There's a chemical in the bark called quinine. And this is what actually helps treat malaria. The Jesuits, of course, said, great. They took a bunch of powdered bark back to Spain with them and announced, we have a miracle cure for malaria. And they called it Jesuits bark, because of course they're not going to give credit to the people who actually figured it out. They're going to take the credit for themselves. The demand for this tree became very, very high in Europe. Malaria was a problem. We've got a treatment. So this caused some problems because the local government in this part of the Andes was refusing to let seeds or small plants out of the country. So there was a lot of pirating going on, smuggling of the seeds out of this part of the world and into Europe, as well as saplings. But the seeds and the saplings didn't make it. They didn't survive the long ocean voyages. If they did survive, they wouldn't survive the European climate. So they were not able to get an established population of these trees in Europe. And the demand for these trees nearly wiped the species out. Eventually, some pirated seeds were acquired by the Dutch. And the Dutch planted them not in Europe. Instead, they took them to their colony on the island of Java in Indonesia, so in the Pacific Ocean. The Dutch were very well known at this time period for their horticultural abilities, their abilities to grow plants. They were able to establish a Chicona plantation in Java. It did take them about 30 years, so it wasn't an easy thing even for them to do. And the British caught wind of this, and so they got some smuggled, pirated, illegal seeds and developed Chicona plantations in India. So now we have plantations outside of the Andes Mountains. Even so, the drugs, the powdered bark of the Chicona tree was very, very expensive. Only the wealthy could afford it. So malaria became a disease of poverty, which is pretty much where we stand today. The places that have the highest rates of malaria pretty much are also the more impoverished parts of the world. Now, quinine, the active ingredient in the Chicona bark, tastes horrible. And some people, it was so bitter that they would throw up. We have taste receptors in the very, very top of the throat. And if they detect strong bitter flavors, it triggers vomiting reflex. So it's not like people were going, ooh, yuck, I don't like it. It was literally a reflex that couldn't be stopped. So Europeans developed tonic water. And they would use tonic water with a lot of sugar and gin to mask the taste of the quinine. So quinine and the gin and tonic allowed Europe to finally invade and colonize Africa and India in the 1800s. Before this time period, malaria pretty much prevented the Europeans from invading and colonizing because it just killed off too many of the Europeans. And the fact that the British owned Chicona plantations really helped the British imperialism movement. So Chicona trees and the gin and tonic really helped the British develop their great empire. And their empire was the largest empire in history, period. They used to say the sun never sets on the British Empire, and that's because they had control over property everywhere on the planet. Before the discovery of quinine, the European troops could not survive long enough to fight in malaria-prone areas. And so malaria was started to be called general anopheles. Anopheles is the scientific name for the type of mosquito that carries malaria. Now, in addition to allowing the Great British Empire to take place, we have to talk also, or we can talk also about malaria and the role of the Panama Canal and how the US ended up owning the rights to the Panama Canal for so long. So if you're vaguely familiar with the map of North, Central, and South America, you know that there's land basically continuous from the Arctic Circle all the way down to Tierra del Fuego at the bottom of South America. And the oceans in the Arctic freeze, and until recently, they were frozen year-round. In the past few summers, there's been a passage in the Arctic for the first time in our history. And going around the bottom of South America, not only did this take a lot of time, but the seas down there are very, very rough. It's the same thing at the southern end of Africa, going around the bottom of Africa, or the Horn of Africa, not the Horn of Africa, the bottom of Africa is very, very hard to cross those seas. And lots of ships were destroyed, lost. If they were carrying supplies, the supplies would get lost. So they tried to figure out how to get across from the Atlantic to the Pacific without having to go either through those really stormy seas with icebergs south of South America, or, you know, across land, because you couldn't go across north of the continents. So there's a stretch of land across the country that is now Panama that is around 50 miles or 80 kilometers wide. And so this area, this part of Panama, and I know it looks funny on this map because we've got the Atlantic up here and the Pacific down here. But if you look at a map, we've got Mexico coming down, South America going down, or Central America going down, and then dipping up and then down to South America. So we're right in this area where Central America kind of goes up for a little bit. Now, people were going across by land. So they would dock here and carry goods across the land to these extensive waterways, these lakes and rivers that didn't quite go across the entire peninsula, but allowed some shipping. And then there was more land work to get down to the Pacific. Now, this area, the land of this in this area, had a very, very high incidence of malaria. And it also had a disease called yellow fever, which nowadays there's a vaccine for, and it's not very common at all. But at the time, it was another one of the big deadly diseases. In addition to that, Panama has a rainy season, which means that bridges, roads, and railways would get wiped out regularly during the rainy season. In 1881, France began construction of a canal with the goal of being able to put goods on a ship and get them all the way across from the Atlantic to the Pacific or back again. They worked on this for about 8 years. And during this time, 22,000 workers died from malaria and yellow fever. So they gave up. In 1897, the human race discovered that malaria was transmitted by the bite of mosquitoes. So we finally figured out how people were getting malaria. And once this discovery was made, the US took over building the Panama Canal in 1904. Same location, same idea. And there was an army physician named William Gorgas. And Gorgas was charged with overseeing the building of this canal. Fortunately, he was a physician. He was an expert in yellow fever, which is another mosquito-borne disease. So he was a good person to be in charge because he could deal with the problems with these diseases. And so he declared war on mosquitoes. And how did he do this? Well, he started putting screens on windows. This is something even today we don't see worldwide, but it makes a huge difference when you've got mosquito transmitted diseases. Window screens are fantastic for helping to protect people. So window screens, he drained swamps, so places of still water where mosquitoes breed. He would put oil on the surface of puddles. So oil floats on top of water, and mosquito larvae have to breathe air from the surface. So if the water is not still, they can't breathe because they get tossed around too much. And if there's oil on the surface, they also can't breathe. So the mosquitoes the mosquito larvae end up dying. And he began fumigating buildings in the canal zones. Now I do need to mention here that the buildings that were fumigated and the buildings that had screens on the windows were the buildings where the white workers were. And the locals who were hired or used to do a lot of the work were not protected the way the white workers were. Granted, a lot of the Black and brown workers, the locals, and that sort of stuff, a lot of them had some immunity, but even so, nobody tried to protect them. Eventually, during the building of the canal, mosquito-borne diseases like malaria and yellow fever were almost completely eradicated from the canal zone. So the area where the canal is now and surrounding lands. Building the Panama Canal took 10 years and cost the US $375 million. That sounds like a lot of money now, but it was $370 million at the beginning of the 1900s. This would be around $10 billion in today's money. During America's building of the canals, we recorded 5,609 lives lost to diseases and accidents. Well, that sounds a lot better than what France did, right? They lost a lot more. Yeah, America only kept track of white workers and their deaths due to disease and accidents. So we really don't know the total loss of life that was the price of creating the Panama Canal. So if you've never seen pictures of the Panama Canal, it is an amazing engineering feat. And even today, it is just amazing that we were able to do this. This is a modern day transport ship. And you can see this is the canal. Look at how close that ship comes to the edges of the canal. This is one of the things that kind of limits the maximum size of ships. Literally, it has a strong influence on shipbuilding nowadays. We can build bigger ships, but we can't get them up through the Panama Canal anymore. So this is a tug, and there's another one on this side, and these are connected to this giant ship to help keep it within that canal. And you can see, of course, here are some cars in the parking lot, and there's a little tiny person right there. The canal is that narrow only at certain places. So as you can see, we've got some areas going across land here, and then a watery route, and then again more cutting through the land and widening this little, what was really kind of a very small river here. We also have to have locks. These are not locks like locking the door. This is an area where the ship goes into the lock. You shut the gates at both ends of the lock, and then you can change the water level, because in order to, if you're going from the Atlantic to the Pacific, the land is above sea level. So you have to take a ship and you get it in this lock and raise the water level, and then it goes into the next lock and you raise the water level. Next lock, raise the water level in the lock, and then it's at the level of the canal. And you have to do the opposite on the other side. So seriously amazing engineering. The canal construction successfully reduced mosquito-borne diseases to a degree never seen before. And other countries started to try Gorgas's methods. And it actually led to the elimination of malaria in much of Europe and much of the United States. Now, we also have to add in changes to land use, where we would drain swamplands or fill them in with dirt, and pesticide spraying. But it really did help. So malaria was well established in the area that is now the United States by 1607, before the United States was the United States. Now, fortunately for us, Plasmodium vivax is more cold tolerant. That's the milder strain of malaria. Falciparum is the deadlier kind, and it just cannot tolerate cold climates. So while Falciparum probably came over, it never really established in Europe or the United States. By the 1800s, malaria was what we call endemic throughout most of the United States, east of the Rockies. And that's going to exclude parts of the Appalachian mountain chain, which is the mountain chain that goes from basically northern Georgia all up the East Coast and, well, on into Canada, and parts of northern New England, basically Maine. It was absolutely in Massachusetts. And this devastating illness persisted in the southeastern US until the 1940s or 50s. So elimination of malaria in the US, one of the big things that we did here was put screens on the windows. If you go to Europe, you find that a lot of Europe does not do this, except on US military bases. Now, I like having screens on the windows personally. I don't like the idea of insects getting in through the windows. I like to have my windows open when the weather is appropriate. And, you know, if you don't have screens, you can also get squirrels, rats, birds, bats, raccoons, all kinds of stuff getting into the house. But that's my personal opinion. Okay. So one of the other things that happened in the US, besides screens on windows, the US Army Corps of Engineers. They went throughout the eastern part of the US and straightened creeks and small rivers. Now, a lot of this was for navigation, but it had the bonus that if you've got a straight creek or small river, you don't have curves, and curves in rivers allow for an area of still water along the edge, the inside edge of the curve, which was where mosquito larvae could survive. So by straightening this out, they also helped reduce mosquito populations. And then there was widespread aircraft-based insecticide spraying. This really started taking off in the late 1800s and early 1900s. Some of these insecticides contained arsenic, which is poisonous, and other chemicals that we now know to be toxic and carcinogenic. Carcinogenic means cancer-causing. And people were treated with quinine. If people were treated with quinine quickly when they first started showing symptoms, then they were less able to pass the parasite on. If you're treated early, you don't have as much buildup of parasite in your bloodstream. It's less likely that a mosquito is going to be able to bite you and transmit it, get enough malaria parasites to transmit it and spread it around. The last big push came in the 1940s and 50s. And this came about because of the Office of Malaria Control in War Areas. So this was World War II. During World War II, a lot of military training camps would be along the East Coast because you're going to ship the troops across the Atlantic to the war in Europe. And so, because malaria was still problematic in the southeastern US, and a lot of military training camps were there, they developed the Office of Malaria Control. And because malaria was mostly in the southeast, they made their headquarters in Atlanta, Georgia. The Office of Malaria Control in War eventually became the Centers for Disease Control, which is still housed in Atlanta. So during this time period, to, again, work really hard to get rid of malaria, or at least control it, they would go around to rural homes and treat rural homes, not in the cities, because more malaria was in the rural areas. And they would treat the houses with DDT, inside and out. They treated over 4.6 million houses, which in the 40s and 50s was a heck of a lot of houses. They also had the military going out and increasing drainage around these houses. So literally, the military would come out, they would find places where water would stand around your house, and either dig trenches so that the water wouldn't remain standing, or improve drainage in various ways. I mean, this is something that we should all be doing today to reduce mosquito populations. And at the time, they would also put oil on top of standing water. If they couldn't get rid of the standing water, they put oil on top of it. Today, most malaria in the US happens in people who are travelers from other countries and immigrants. And last statistic I got, there were about 1,500 to 2,000 cases a year and 5 deaths. So we did a pretty damn good job. We did a lot of environmental destruction at the time. So DDT, we have to talk about DDT. DDT is, or was, a very effective pesticide to deal with mosquitoes. Just like bacteria creating resistance to antibiotics, but any disease getting resistance to treatments, well, mosquitoes started getting resistant to DDT. So we would get new outbreaks. DDT also had horrific effects on other wildlife. In the lower 48 states, the bald eagle was nearly wiped out because of DDT. So DDT is what we now call a forever chemical. As far as we know, it doesn't break down. So when you spray DDT to eliminate insects, some of that DDT ends up in the waterways. And of course, dead insects are easy prey, and you're killing insects in the water as well as on land. So fish eat the insects, bigger fish eat the smaller fish, and DDT builds up in their bodies. And what do bald eagles eat? Fish. So we had declining fish populations, and we had declining bird populations. Any bird that eats insects went into decline. And during breeding season, almost all species of bird need insects. Pigeons and doves are an exception, but the songbirds got to eat insects. The hawks, a lot of hawks eat birds. So we were seeing large declines in everything. And this massive shrinking of the population led to Rachel Carson's book, her seminal work called Silent Spring, which was describing the decline in birds and predicting the loss of songbirds in the US. DDT does not break down in the body. So if you eat fish or birds like ducks that are exposed to DDT, you get DDT in your body. And every time you eat fish or ducks that have DDT in their bodies, you get more DDT into you. We don't know if it will ever break down in the environment. If it does, it's very, very slow. And we also see nowadays high rates of cancer in marine mammals, dolphins, seals, sea lions that are eating the fish that ate the insects that had DDT exposure. Right now, we're seeing high levels of DDT in marine mammals off the coast of Southern California. It turns out that when DDT was banned, and it was eventually banned because it is so nasty, the companies that manufactured the DDT couldn't figure out what to do with this pesticide that they'd already made. So, did they try and do the right thing? Maybe some of them, but we know corporate America does not just try and do the right thing. They try and do the profitable thing. So a lot of these companies put the DDT into barrels and dumped those barrels in the ocean. These are metal barrels in salt water. They're breaking down. And now it's very clear that these barrels are leaking into the ocean off the coast of Southern California, exposing marine mammals, getting into the food chain, including in wild-caught fish destined for human consumption. Nobody has a clue how to clean this up. Not a clue. As far as I know, nobody's even trying anything, because if you move the barrels, they're rusty, they're going to break open. And we don't know how to get DDT out of water. So we have, even now, decades after DDT was banned, and DDT was banned in 1972, we're still having to worry about this. So what does DDT do to people? So I talked about how over 4.5 million houses were treated with DDT in the 40s and 50s. We also had aerial spraying from airplanes, and we would have trucks. So here's a picture of a truck spraying DDT. Do you see these guys wearing protective equipment? No, you don't. Do you see these kids? Yeah, they're not wearing protective equipment either. When I was a kid, our community would spray pesticides to deal with mosquitoes. I mean, they still do it nowadays in places. If they start seeing things like the mosquito-borne encephalopathy diseases in Massachusetts, they'll spray areas to try and kill mosquitoes. Well, what do you think kids do when they see a truck with a big cloud coming out the back? Kids ride their bikes in and out of the cloud.
Yeah.
Sorry, I think I talked over somebody there.
Yeah, I said they like run towards it, but yeah, same thing.
Yeah, they run towards it, they play in it. Yes. So this is basically an unplanned, uncontrolled experiment on the long terms of DDT in humans. We know that DDT disrupts hormones. And we know that women exposed to DDT have a high risk of breast cancer.
I'm a little confused. Isn't it just kind of common sense that this was going to end up bad, just spraying chemicals with no protective equipment, even if they thought it was safe, just in general? It's like basic, like if you're, doing a lab and you're playing with sugar and water, you still wear your safety equipment. So I'm not really getting it.
Yeah, we were not nearly as safety conscious back in the 40s, 50s, and 60s as we are now.
Mm-hmm.
Even when I was in college, we weren't nearly as safety conscious as we are now. And labs didn't have the same safety requirements. So as a society, we've gotten better at thinking about things like that. But I am sure that there are things that we are doing today that 50 years from now, people will go, didn't they think about that?
You're right. Right now in New York City, Homeland Security has been testing out a system in the subways where they're spraying like particles to try to like biotrack people. If there's like a terror attack or something, they can spray them. But they've been doing that. It's open information, just not information a lot of people would know about.
Yeah.
And so I guess they still do stuff like that.
Yes, they do. Yes, we do. And it doesn't even have to be stuff like that. One of the big things that I think 50 years from now, people will be horrified by, and people who are in the know are horrified by it now, but nutritional supplements are not tested or regulated in any way, shape, or form. So right now, we're doing a huge experiment on people to see what these nutritional substances can, what's going to happen. We don't
I have
know.
a question about those. Are
Yeah.
those plant-based or are they like synthetic, even though they could be plant-based? Or are we not sure because it's unregulated?
We're not sure because it's unregulated.
Uh-huh.
Yeah. And since it's unregulated, it doesn't even have to contain what it says on the label. So I think that's going to be something that people become horrified at in the future. But we don't know. I mean, that's the thing. We don't know yet. You have to, we as individuals learn by making mistakes. Well, we as a society learn by making mistakes too. Okay. So DDT disrupts hormones, can increase the risk of breast cancer. It gets more complicated. Women who were pregnant and exposed to DDT and had daughters, their daughters would have 5 times higher than normal risk of breast cancer and high rates of infertility. So not only were the women who were exposed at higher risk, but their unborn daughters are now at higher risk. And in fact, their granddaughters are also at higher risk of breast cancer and early onset puberty. So when I say granddaughters, it has to go from mother to daughter to granddaughter. Their sons probably have higher risk of breast cancer, but we don't really track that. And breast cancer in men is a lot rarer than in women. But certainly the granddaughters are showing signs of this. So if we just look in general at people exposed to DDT and their offspring, daughters and sons, we see higher rates of obesity compared to people the same age, same socioeconomic status, not exposed. Higher rates of cancer, again, comparing to this, same socioeconomic rates of people who were not exposed. And women who were exposed before they were born, their children also have higher rates of obesity and cancer. So DDT was banned, as I said, in 1972. It is still used in some countries that have high rates of Plasmodium falciparum and extreme poverty. People are being a lot more careful about it and not just spraying it everywhere. But it is being used. And even today, we are using pesticides to deal with mosquito populations. Lots of people have a lawn service that sprays pesticides on the lawn. Not DDT, but different pesticides and herbicides. Again, not DDT. Now, on the good side, it helps reduce mosquito-borne diseases. But we're doing it again. You guys just asked about this. Why do people do this? The pesticides and herbicides that lawn care companies spray on your lawn, they are supposed to be wearing extensive protective equipment. Bunny suits, masks, goggles, gloves. They usually don't, but they're supposed to be. We are conducting another experiment. What's going to happen in the long run based on our exposure to lawn chemicals? So people can, not to fight diseases, but so people can have a perfect lawn. So, do we know if this is going to be a problem? We're starting to see early warning signs. Insects are on decline worldwide. This is a huge, potentially a huge problem. Even though we don't think we need insects, we do. We need them for our own survival. And we need them if we want to have birds. And birds are on decline worldwide. We're getting rid of the insects that they need to feed their offspring. We know that exposure to these chemicals that we're using on lawns nowadays can contribute to neurological problems. like Parkinson's disease. At this point, we see this primarily on farm workers, but I suspect that lawn care workers are going to start showing up with high rates of Parkinson's disease in the not too distant future. I did tell you at the beginning of the semester that this was not going to be a cheerful class, right? Okay. So today, well, okay, this map is from a few years ago. Okay, so this map was from 2004, and my data is from 2016. So a few years ago. But in 2016, half of the world, 91 countries, still have malaria. And our best estimates are that there are 216 million cases and just shy of 500,000 deaths every year due to malaria. 90% of the deaths in Africa, and most of these are in children under 5. So we can look at this map and we can see how widespread malaria was before the 1900s. So you can see a little bit up the Pacific coast of the US, all the way up into New England, into the Great Lakes, not in the Rockies. So there's the big mountain chain, it goes down through Mexico, and that stayed pretty much clear. You can also see the Andes mountain chain right through here. But you can see, yep, Massachusetts, looks like New Hampshire and Vermont too, had malaria until the 1900s. And then the southeastern US until the 1940s or 50s. And the purple areas are those that still had malaria as of 2002. So we are seeing continuing declines, but it is still a huge problem. So what can be done? We can do prophylaxis. Prophylaxis means preventative measures, and these include window screens and bed nets. So these are a couple of kids in Africa, and this is their mosquito net. Mosquito nets are relatively cheap. Heck, window screens are relatively cheap and highly, highly effective at reducing malaria. Insecticide-treated bed nets can be made for about $5 each. Now, this is, like, as I said, I think this data was like a few years ago, 1916-ish. $5 a net, that's not bad. But in a lot of places where malaria is prevalent, people earn less than $1 a day. There is an organization called Nothing But Nets that provides bed nets for these impoverished areas in Africa. And like I said, whenever I travel to a malaria area, I take my own bed net and I leave it. Indoor residual spraying can help. So the mosquitoes that specifically transmit malaria, after feeding, they rest on the walls for up to an hour to digest. And so you can spray the walls with pesticides. And the mosquitoes, I mean, yes, they just had a blood meal off of somebody, but then they go hang out on the wall and die. and they're chemicals that'll last 3 to 6 months. Resistance is starting to show up to these pesticides. When we talked about medications, how taking medications can prevent infections, but they have nasty side effects, and people quit taking them, and that causes resistance. And long-term use to anti-malarials can cause liver toxicity, which you can't live without a liver, so that's not great. The role of climate change. Oh, more bad news on the malaria front. As the climate is changing, the distribution of the mosquitoes who carry malaria are also going to change. Some of it is going to be temperature related and some water related. We're already seeing species of mosquitoes moving into areas where they have not been present before. It's hard to predict. It's hard to predict climate change. We can't say this area is going to get wetter and this area is going to get hotter. We're just not sure. The American tendency to use window screens means it's not likely that malaria will become established in the US. So that's good news for us. And some great news came out, excuse me, some great news came out last week. Literally last week, on April 13th. The country of Ghana, which is right here in Africa, so this is the northern part of Africa. Here's Saudi Arabia. Here's Egypt. Here's the Democratic Republic of Congo. We've talked about that a lot this semester. And here's Ghana. On April 13th, Ghana approved a new vaccine for malaria. This vaccine is still technically in clinical trials. The World Health Organization has not approved it for use, but Ghana is starting to give it to their communities, specifically to the young children. Young children are the highest risk for loss of life due to malaria. The early clinical trial results show that it is 75% effective, which means 3/4 of the people who get this vaccine will not get malaria, which is a huge improvement for a disease that infects so many people and kills so many people every year. The good thing about this drug is it's relatively cheap. It's relatively easy to make. There's a facility in India that is capable of producing large amounts of this. Like I said, the World Health Organization hasn't approved it yet, but we're kind of expecting that to come along later this year. There has been an earlier vaccine approved that's only about 30% effective, so not great. And it requires 4 doses. And it's more expensive and difficult to make. So there's never been a lot of it. So this new vaccine has a lot of hope. If it works well, maybe we can get rid of malaria. Wouldn't that be awesome? Okay. Oh. That ends our discussion on malaria. Does anybody have anything they want to say or ask about malaria or anything we've talked about today? Well, okay. In that case, I'm gonna let you guys head out a few minutes early, get an early start on, well, the rest of your day. And I will see you guys next Tuesday.
Thank you.
All right. Have a good weekend.
Thank you very
Thanks.
much.
Bye, everyone.